Hi, this is Alex from devstories.eu. GitHub Actions, Episode 5 of 14. Developers often mint long-lived personal access tokens for basic repository tasks, leaving permanent credentials sitting in their codebase. But for most GitHub interactions, you do not need to create a token at all. There is a secure, ephemeral token waiting for you in every job. This is the focus of today's episode, the security boundary, secrets, and GitHub_token. When you trigger a workflow, GitHub automatically provisions a unique secret called the GitHub_token. This is not a standard personal access token. It functions as a short-lived GitHub app installation access token. It exists exclusively for the duration of the workflow job. The moment the job finishes, or after a maximum of 24 hours, the token expires and becomes completely useless. A common mistake is generating a permanent personal access token just to have a workflow add a label to an issue or post a comment on a pull request. This expands your attack surface unnecessarily. The built-in GitHub_token already possesses the permissions needed to interact with the repository that triggered the workflow. If your job needs to add a label to an issue, you pass this built-in token to the step executing the API call. No permanent credential is ever created, stored, or exposed. That covers interacting with GitHub itself, but your workflow will inevitably need to talk to the outside world. This is where custom encrypted secrets come in. When you create a custom secret, it does not sit as plain text on a GitHub server. The value is encrypted locally using libsodium sealed box before it is even transmitted. The encryption relies on public key cryptography. When you add a secret via the web interface or API, GitHub provides a public key. Your client uses that key to seal the box. Only the isolated runner virtual machine holds the corresponding private key required to open that box, and it only decrypts the payload at the exact moment the job executes. You can define these encrypted secrets at different levels depending on your architecture. Repository-level secrets apply to a single codebase. Organization-level secrets allow you to share a single credential, like a production database password, across multiple repositories. This centralizes credential management but requires strict control. Organization secrets use access policies, where you explicitly define which repositories are allowed to read the secret. Let us apply this to a concrete scenario. Say you have an organization-level database password required for a database migration step. You do not want this password accessible to the entire workflow. GitHub Actions enforces a strict security boundary here. Secrets are not automatically injected into the environment of every step. You must explicitly map the secret to an environment variable in the specific step that requires it. When you write the workflow file, you access the encrypted value using a specific context reference, calling it from the secrets object, and assign it to a local environment variable. Because you mapped it explicitly, the step before the migration cannot see the password, and the step after it cannot see the password. Here's the key insight. Security in automation is about minimizing lifespan and limiting scope. Rely on the ephemeral GitHub_token for internal repository actions to avoid managing permanent credentials, and strictly map encrypted secrets only to the individual steps that require external access. That's your lot for this one. Catch you next time.